Gravity. It's the invisible force that keeps your feet on the ground and the air around you. It's so constant, we barely notice it, yet without it, life as we know it couldn't exist. Gravity is the silent architect of the cosmos, holding the moon in orbit, guiding planets around the sun, and shaping galaxies. The atoms in your body were forged in ancient stars, scattered, and then gathered by gravity to form you. You are, quite literally, a child of the cosmos, connected to the farthest star by this fundamental force. Every time you stand on Earth, you're feeling the pull of a planet, a reminder that you're part of something vast. Gravity is both intimate and universal, a constant presence and the engine of cosmic creation. So, next time you feel the ground beneath you, remember, you're anchored to a spaceship hurtling through space, held safe by gravity's embrace. It's the force that binds us all, from the smallest pebble to the largest galaxy. Without gravity, there would be no stars, no planets, no us. It's the thread that weaves the universe together, and it's always there, holding you close. For centuries, people thought the heavens and earth followed different rules, until Isaac Newton changed everything. Legend says an apple's fall inspired Newton to ask, could the force pulling the apple down also reach the moon? He realized the same force that makes apples fall keeps the moon in orbit, a revolutionary idea. Newton's law of universal gravitation stated, every object attracts every other object, with a force depending on their masses and distance. With this, Newton could predict planetary motion, tides, and comet paths with stunning accuracy. He described gravity as an invisible, instantaneous pull. If the sun vanished, Earth would instantly fly off into space. But this idea of instant action, at a distance, raised a paradox. Light from the sun takes 8 minutes to reach us, so how could gravity act faster than light? If the sun disappeared, would Earth feel it instantly, or after 8 minutes? Newton's law worked, but this mystery hinted at a deeper truth. The universe's speed limit set by light posed a challenge Newton's theory couldn't solve. This crack in the foundation would set the stage for a new revolution. The question lingered, how does gravity really work across the vastness of space? The answer would change physics forever. Picture gravity as an invisible rope connecting the sun and Earth, always taut, always pulling. In Newton's view, if the sun moved, Earth would feel it instantly, no delay. But Einstein's special relativity declared, nothing, not even information, can travel faster than light. If the sun vanished, we'd still see its light for 8 minutes, but Newton's gravity would have Earth fly off instantly. That's a paradox. Earth would react before the light even faded. Gravity, it seemed, was breaking the universe's speed limit. This contradiction showed Newton's theory was incomplete. Gravity couldn't be an instantaneous pull, it had to obey the cosmic speed limit. Einstein saw the problem, either relativity was wrong, or our understanding of gravity needed a revolution. He chose to rethink gravity itself. It took Einstein a decade of thought to find the answer. His solution would not just fix the paradox, it would transform our view of space, time, and the universe. The stage was set for a new theory. Gravity was about to become much stranger and much more beautiful. The next step, reimagining the very fabric of reality. Einstein was ready to change everything. Einstein's breakthrough began with a simple thought. A falling person feels weightless. In free fall, gravity seems to vanish. An object dropped beside you floats. This led Einstein to a radical idea. Gravity isn't a force, but a feature of the universe's geometry. He merged space and time into a single, flexible fabric, space-time. Massive objects like the sun curve this fabric, creating dents that guide the motion of planets. The Earth orbits the sun, not because it's pulled, but because it follows the curve in space-time. Gravity, in Einstein's view, is geometry, the shape of the universe itself. Your weight is the result of space-time's curve pushing up on you, not the Earth pulling you down. A falling person feels weightless because they're following the natural path through curved space-time. This is the heart of general relativity. Mass tells space-time how to curve, and curved space-time tells matter how to move. No more invisible ropes, just the elegant dance of geometry. Einstein's vision solved Newton's paradox and revealed a universe far stranger than anyone imagined. Gravity became the shape of reality. The cosmos was now a dynamic, flexible stage, and we were all moving along its curves. The universe would never look the same again. Imagine space-time as a stretched rubber sheet. Place a heavy ball in the center. It creates a deep curve. Roll a marble nearby, and its path bends toward the ball, not because it's pulled, but because it follows the curve. This is how planets orbit stars. They're caught in the curves created by massive objects. The more massive the object, the deeper the curve. Even light follows these curves, bending as it passes near massive bodies. In 1919, astronomers saw starlight bend around the sun, confirming Einstein's prediction. Gravity isn't a force, it's the shape of space itself. The invisible fabric is real, and it shapes everything we see. So, what if the sun vanished in Einstein's universe? The sun's mass curves space-time. Earth orbits in that curve. If the sun disappeared, the curve wouldn't flatten instantly. Instead, a ripple, a gravitational wave, would travel outward at the speed of light. Earth would keep orbiting for 8 minutes, just as we'd keep seeing the sun's light. When the ripple arrived, Earth would fly off, and the sky would go dark. At the same instant, gravity, like light, has a speed limit. The paradox is solved. Gravity's changes travel at light speed. The universe is a dynamic, flexible fabric, constantly shaped by matter and energy. Most gravitational waves are tiny, but cosmic events, like colliding black holes, can send powerful ripples across space-time. For decades, these waves were just a prediction, but the search to detect them was about to begin. The most powerful gravitational waves come from the universe's most extreme events. Imagine two massive objects, like black holes, spiraling together, churning space-time and sending out ripples. Gravitational waves are not waves in space, but waves space itself. As they pass, they stretch and squeeze everything, but the effect is unimaginably tiny. Detecting them seemed impossible for decades, yet these waves carry pure information about their violent origins, passing through matter unimpeded. They are the universe's messengers, telling stories light cannot. If we could hear them, we'd open a new window onto the cosmos. Scientists built LIGO, two giant detectors, each with 4-kilometer arms, to catch gravitational waves. Lasers bounced between mirrors, waiting for a tiny stretch or squeeze in space-time. For years, LIGO listened in silence. Then, in 2015, both detectors registered a faint, fleeting signal, a chirp from the universe. Analysis revealed the source over 1 billion years ago. Two black holes, each dozens of times the sun's mass, spiraled together and merged. In a fraction of a second, 3 solar masses worth of energy was released, not as light, but as gravitational waves. For the first time, we had directly felt a tremor in space-time. It was like gaining a new sense. Suddenly, we could hear the universe. This discovery confirmed Einstein's prediction and opened a new era of astronomy. We could now listen to the cosmos, not just watch it. The universe had a new voice, and we were finally able to hear it. The detection of GW1-914 was just the beginning. The symphony of the cosmos was waiting for us. Our journey to understand gravity has transformed our view of the universe. Gravity is not just a force, it's the very fabric that connects everything. With gravitational waves, we can now listen to the universe's most dramatic events. Each wave is a messenger from the past, carrying the story of cosmic birth and collision. Science lets us decode these messages, revealing our place in the cosmos. Gravity connects apples to moons, us to the stars, and space to time. When you feel Earth's pull, you're feeling the shape of the universe itself. The universe is alive with echoes of creation, and we're just beginning to listen. The greatest secrets are still out there, waiting to be heard. Gravity's song continues, and we are part of its endless melody.